86 minus 22. So let's set this up. Okay, so we're going to take that first number, 86. I should separate the 6 a little bit more, right? Tens and ones. 22 is 2 tens, 2 ones, and we're going to subtract this by place value. If you can't do this in your head, that's fine. But again, we can just do this by fingers by place value as well, which means we don't have to look at it like 80 minus 20. It's just really 8 minus 2. But we start with the ones place value, 6 minus 2. So 6 minus 2, 6, 5, 4. So there's 2 fingers up. We end up with 4 ones. And then 8 minus 2, 8, 7, 6. Boom. So it ends up being 64 after subtracting 22 from 86. 1.4, adding and subtracting applications. You'll get used to this. Applications is a fancy way to say word problems. And since we love word problems so much, this should go very well. But our objectives, I can find and finish patterns. I can translate and solve word problems. There we go, bam, word problems. And then parameter, which is, I don't know, to me it's kind of a direct math application, but technically they'll be using words to describe the parameter. So there you go, word problems, all right? Patterns. When you look at patterns, and by the way, pattern recognition should not be limited to math. If you can get used to just general pattern recognition, I mean, detectives use this in law enforcement as well, but pattern recognition will help you immensely. And so there's a lot of math that really is not useful in life, but pattern recognition is one of those that should be helpful. Now, this is just math patterns, so we're looking, it doesn't really matter if you look at left, right to left. We tend to look at it left to right, and then we're looking at whichever operation has been used. Now, we've only gone over addition and subtraction, so that's the only thing we should be looking at, okay? Whether you go left to right to left doesn't really matter, and I'm sticking with left to right. We want to see if we see the values going up in value, then addition has to be used. That's the only way we can make them go up right now. If we see that the pattern is going down, then some form of subtraction has been used, and then we've got to figure out how much. But it should be the same amount every time, okay? So when we see addition, you know, if they add 5 every time, then we should see they're always adding 5, or if they add 10 and so forth. Or if it's subtraction, you know, maybe they subtract 1 every time. You have to find out what was added or subtracted. Yeah, so that's what we got to figure out, and that will help us to predict future values in the pattern. So we look at something like this: 53, 59, 65, 71. Again, the same value should be being added to the values given here, and if we can just figure out what that is, then we should be able to add that every time. So the truth is that we can look specifically at the first 2 numbers, and then we should see the repeating pattern with the other numbers that are given. So in other words, 53, we got to do something to 53 to get 59. Now, since I'm going from left to right, so I'll put an arrow on that red line there, I see that I start with 53, and then I get 59, which is bigger, so I am expecting to add something to 53. Now, we could look at number sense here, right? We could make a fact family out of this. That's great news. Yeah, the fact family would show you take 59 minus 53, and you get 6. So I'm skipping a little work there. I guess there is no borrowing, but yeah, you'd have to add 6 to get the 59. So I like to show it like this. You don't have to. There's never a requirement to show it exactly like I do. But I'd say 53 plus 6 is 59. So let's see, 59 plus 6, what is that? 59, sorry, I should put it here, 59 plus 6. So 9 plus 6 is 15, carry the 1. And then we got in the tens a 1 and a 5, which would be 6. So you see how we got the 65 right there? And this should be a consistent pattern. So that means the next step would to say 65 plus 6, what would that be? So 65 plus 6, 5 plus 6 would be 11, carry the 1. In the tens, 1 plus 6 is 7, 71. Boom, we found it. So we should now know how to find these next 3 values. Okay, so all we're doing is adding 6 to each of these to get the next one. And the truth is, now that we know that and we see that it's consistent, you could do it forever if you wanted to, or until you're, worn out from doing all that addition. which is quite enjoyable. But either way. Now, that's because we went from left to right. If for some reason you're like, you know what, I want to go this way, then it's just reversing that operation. So instead of having it be plus 6, you'd have to go this way, you'd have to subtract 6. So you'd say 71 minus 6 would be 65. 65 minus 6 would be 59. And of course, you'd end at 53 because we don't have any boxes, but you could put them there. So translating words, again, we're only focusing on these two operations for now. We got addition and subtraction, and just so we can remember the signs, even though we saw this on the last slide, addition is a plus sign, and then a subtraction, a minus sign. So are these all that we're going to see? Possibly not. It just depends on the context that they give us. So total, combined, added to, sum, increased, altogether. I guess one of the more common ones is sum if it's an addition. Added to is kind of direct there, maybe total, I don't know. So subtraction, minus, remaining, leftover, difference, less, how much more. These two here at the end, though, we got to be careful with because less than and subtracted from, they're going to reverse the order. So addition, like we've seen, the order doesn't matter, right? If you want to do 7 plus 3, which is 10, you can. But if you wanted to, for some reason, do 3 plus 10, you could do that as well. But I can't do that with subtraction. I cannot do 7 minus 3, which is 4, and then do 3 minus 7 is 4. That does not work. So we have to be careful with this one. We have to be careful with order and then how it's being used. So I like to think about this with money, which I've said before that I like so much, probably because I don't have very much of it. But let's look at one of these examples. So someone give me a number. 5. 5 less than, something less than 5. Someone, well, no, hold on. Something more than 5. 7, boom. Okay. Now if I say 5 less than 7, here's what we end up with sometimes, okay? Because we're used to direct translation, meaning you just translate, you're like, okay, less than means subtraction, so you say 5 minus 7, right? But that is false. That is the wrong way to interpret it because you have to have the 7 first, and then you've got to go 5 less than it. Less than it, yeah. Okay, so, again, the money thing, sometimes it helps. So if I said $5 less than $7, how much money do you have? Some students no longer need to see the numbers. They'll just be like, oh, I know I got $2 because of the way that's how money works, right? Well, that's because you'd have to take the $7 and then subtract the $5. So again, the wording does matter with subtraction because of order. But again, if this was some form of addition, then it would not matter. So if we've talked about this before, if it helps to add those dollar signs to your numbers, do it. Doesn't matter, as long as it helps. The other thing with translating words is that since these are word problems, and most students don't actually love word problems, you may have to read and reread these several times. I want to say we've talked about this before, but I could be getting classes mixed. Reading once, sometimes you can do it, okay? But the truth is you probably will have to read the problems 5 or 6 times. And so students in the past have been like, dude, I've read it 6 times and I still don't understand what it wants. Okay, read it 7 or 8 times. Okay, so just prepare for that. That's part of the, right, we're doing 6 hours in class and then 12 hours outside of class. That's part of your 12 hours right there is reading and rereading the word problems because sometimes they don't make sense directly. On this chart, it's less than, which changes the order. Less is a direct translation, meaning if you see the word just less by itself, it usually means that you're going to take a number and then subtract another one. So let's look at these two. We got the sum of 98 and 73. Okay, so let's evaluate that. We'll get to this one here. But it's saying sum, S-U-M, sum, which I know is an addition problem. And this is just saying to translate, so we don't actually need to solve this or evaluate it, which, I mean, you're welcome to do. I'm just not going to. Sum, since sum is addition, I don't really care about the order, and I don't think the assignment does either. But it's the sum of 98, so that's 90, that's 9 tens and 8 ones, 98, and 73, which would be 7 tens and 3 ones. And then, of course, we could add those together. But again, this is direct. Sum is a direct translation between, you just take the number that's given first and then the second number, list them, and then you can put the addition sign between. I kind of went in the reverse order. I put the addition and then the two numbers. That's all we need out of this. Just can you translate the sentence? Okay, so I'll write it here just for the video's sake. Yeah, it's a total of 12, so that'd be 12 and 11. And it's a total right there, so we're looking at an addition problem. Subtract 21 from 83. So we got to be careful on this because we're subtracting from a value. Specifically, we're taking 21 here. Okay, so that's 2 tens and 1 1. But it's going to be subtracted from a value, meaning you have to take that value and then you've got to subtract the 21. See what I'm saying right there? And again, the order would matter because we look at this, we say, okay, we're subtracting from 83. So you'd have to start with 83 and then take away 21 from that. So again, since order does matter on this one, if it helps you to say, well, subtract $21 from $83, maybe that helps you figure that one out, okay? But again, the important thing is that we don't get this mixed up. What we don't want to see is 21 minus 83, not just because we haven't gone over negatives yet, but also because it's a mistranslation right there. I'll rate it 84 less 65. Try it out. 84 less, so less would be another form of subtraction. But this one is a direct translation, taking 84, so 8 tens and 4 ones. And then subtracting 65, 6 tens, 5 ones. So translate and calculate. So we're going to have to translate this one and then calculate it. So you have $23 in your checking account. You guys gave your pal more money on this one, whatever. And your pal has $42 in their checking account. How much was there together? So this one together, right? Meaning you've got your money and your pal has their money. And so we're going to look at putting them together, which would indicate that we are looking at an addition problem. So I'm just looking at the translation now. So on the assignment, there's usually 2 boxes, one for the translation and then one for the actual final value together. So I'm going to start with how much you have, which it says is 23 bucks. And then I'm going to add to that your pal's amount. And your pal, it says, has $42. That is our translation right there. Of course, how much they have together, we're just going to take those two values and add them together. So I'm going to do this by place value. Now, again, some of you, I think, are getting fairly quick at this, which is great news. So please be patient while we go through this for everyone else. So in the ones place value, starting the ones, 3 plus 2. So again, 3 fingers up. You can put 2 more fingers up or start with 3 and then add 2. You're going to end up with 5 in the ones, nothing to carry. And then for our tens, 2 plus 4, 2, 3, 4, 5, 6. So we end up with 65. Together, you have $65. This one, the town had a population of 52,542 in 1981. By 1996, the population in that town had increased by 6,873. Estimate the town's population in 1996 by first rounding these two numbers to the nearest 100. So we're combining a couple things on this one, right? You have the operation, which will let you perform, but we also have to round this to the nearest 100. Okay, so think about how we were rounding in the last 2 sections, I believe, and then try this one out. Right? Take a minute, try it out. If you make lots of mistakes on this, good for you. That's what we want right now. We want you to make lots of mistakes right now so we know what we need to fix. So on this one, just like with the problems we've done before with estimation, we have to estimate first. We have to round first. Okay, so rounding, it says we got to round to the nearest 100. So I'm going to take our first value, that's the population in 1981, 52,542. Let's take a look at that, 52,542. And we're going to round this to the nearest 100. So I got to find my hundreds place value, right? So So I've got ones, tens, and hundreds. That's the 5, the second 5. And immediately to the right is a 4, which means that the 5 will stay the same. So the 5 in the hundreds stays a 5. All the place values to the right in the tens and ones will become zeros. And nothing has affected anything to the left. So our thousands place value stays a 2, and our 10,000s place value stays a 5. Well, let's see how the rest of it goes. Then we have the 6,873, and we have to round this one too. So again, we identify the hundreds place value, which is in the same place value because I've lined it up. But immediately to its right is a 7, which means I have to add a 1 to the 8. So my new value from the 6,873, it would be 900s. Again, we've gotten rid of the tens and ones, and there would have been 6 of the thousands right there. So we have that, and this is an increase in the population, which is an addition problem. So we're going to add these two values and see what we get. So the ones and tens becomes very nice because 0 plus 0 is always 0. And then 5 plus 9, again, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now again, that'd be 1400s. I'm going to take that 1,000 and just mix it with the other thousands. So 1 plus 2 is 3, plus another 6. Hopefully we got 9 out of that. And then the 5 in the 10,000s just drops. So let's see, this is a word problem though. And when we have word problems, we should always expect some kind of label. So it was a population, so I'll put people. Now this is just an estimation, and that's okay. But that's what we should get by estimating this, rounding to the nearest 100. Let's do this one. You grow 631 tomatoes and are able to sell 250 of them in 3 days. How many tomatoes do you have remaining at the end of the 3 days? So we're going to start, right? You're starting with the 631 tomatoes. Now we're going to sell. So what operation are we going to use for sell? Sell is going to subtract, and it says you sold, so we're going to subtract 250 tomatoes. Now again, I've lined that up so that we can just solve this. And this should tell us how many tomatoes are left after the 3 days. So in the ones place value, 1 minus 0 is 1. In the tens place value, now we got 3 minus 5, right? We don't have enough tens. We only got 3 tens to take 5 away. So I'm going to have to borrow from the 6. So the 6, I'm going to take 1 away and give it to the tens place value. It's 13 minus 5, so 13, 12, 11, 10, 9, 8. And then in the hundreds place value, 5 minus 2, 5, 4, 3. 381. Now, like I was saying on that last slide, when you see word problems like this, don't leave the answer, at least when you're writing it out, because on tests you're going to have to write them out. If you write 381 like this on a test, and this was a test question, minus 1 point, because you're missing the label. It would be 381 tomatoes. And if you want to be specific, after 3 days, but that's more writing than I want to do. So a patio set is on sale for $210. Its regular price is $634. What is the difference between the regular price and the sale price? You guys try this one out. Okay, so we have the regular price on this one, the $634. 634, 600s, 3 tens, 4 ones. And the new price is $210. So 210. It's asking for a difference, which is a subtraction problem. So we're going to take these two numbers and subtract them. And if you got these mixed up, you'd have 210 minus 634. The problem with that is that now you're taking way more than you have altogether. Even borrowing isn't going to help you. So make sure it is set up this way. We shouldn't end up with anything negative right now. So in the ones place value, 4 minus nothing would be 4. 3 take away 1 would be 2. That's our tens. And then in the hundreds, 6 minus 2, another 4. Now again, 424 is okay, 424, but make sure to label it. $420 difference between the regular price and the sell price. Now, if I had read that a second time, that would have been probably a little bit more helpful. Notice it's a difference between the regular price and then it's the sale price. That actually told us the order that it should have been subtracted. So if I didn't stack it like I did, the regular price, which was $634, and then it's a difference with the sale price, the regular price and the sale price, which would have been $210. So again, this would have been a direct translation here, but we would have stacked it anyways. Well, that brings us to perimeter. So sometimes the perimeter stuff throws students off because sometimes it really is because of the shape. And as math people, we say if you see the shape, then it should help. But sometimes it causes more confusion. So we have to be careful with this. Perimeter is just the distance around the outside edge of a shape. So you could say, well, couldn't you just walk around the middle right here? You could, but that's not perimeter anymore. That's just, I don't know what the heck that is, okay? So you got to take the outer edge of the shape and then walk around it. Or it's kind of like closing it in. So perimeter, it's the sum, which means we are going to be adding all of the outside lengths. And then the unique thing about rectangles is sometimes they won't show all the numbers. Like they'll say this one right here is 5. And then this one right here is, I don't know, 10, something like that. But they won't show the values here and here. But opposite sides have the same value. So if the right side is 5, then the left side is also, it must be 5. And if the top is 10, the bottom also must be 10, okay? So they won't show those numbers all the time, but we can know what it is because it is a rectangle. Excuse me. If you wanted the perimeter of this one, you just do 10 plus 5 plus 10 plus 5. I started at the top. Some students like to start on the left, the bottom, the right. Doesn't matter. But in the end, you should see 4 numbers being added together. All right, so the perimeter on this one, we have 11 on the left. It doesn't give us units, so we're not really expecting a label on this one. So that means it's going to be 11 on the right as well. And then we also have 25 on the top, which means it has to be 25 on the bottom too, okay? So we're going to take these values, all 4 of them, and I'm going to show all 4 of them added together. So we got, I'm going to start on the left. We got 11, and then the top is 25, and then the right side is 11, and then the bottom is 25. So that's all 4 sides. Since we're looking for a perimeter, we're actually going to need to add these together, right? Because we're looking for a sum. Now, we talked about this before. If you have lots of numbers being added like we do here, you can add all 4 of them at the same time and just stack and add. But I'm going to do this 2 numbers at a time. So I'm going to start with just these 2. So that'd be 11 plus 25. So in ones, I've got 1 plus 5, so 1, 2, 3, 4, 5, 6. There's 6, and then 1 plus 2 would be 3. So that's 36 right there. And then I've still got the plus 11 plus 25. So again, I'm going from left to right, 2 numbers at a time. Now I've got to do 36 plus 11. I'll do that up here because we got space. 36 plus the 11. So that would be 6 plus 1 is 7. 3 plus 1 is 4. 47. And then we got the final number to add, which is the bottom for us, 25. So we put these 3 numbers together, which is 47. Now we got the 25 there on the bottom. So combining these two, 47 plus 25. So 7 plus 5, 7, 6, 7, I went the wrong direction. 7, 8, 9, 10, 11, 12. So you can put 12 there, but the 1 in the tens place value has to carry over. So 1 plus 4, 1, 2, 3, 4, 5, and then plus 2, 6, 7. So 72 would be the final perimeter for this problem. Sometimes what students will do, they'll say, well, 11 plus 25, there's 11 plus 25. And this would be the associative property where students are saying, I'm going to do these 2 and these 2 at the same time, and then you would have gotten 36 plus 36, which still equals 72. So a few different ways to look at it, but you get the same answer either way. And usually would put units on this, but none to put on for here because we don't know what these units are. So let's find the perimeter of this one. In fact, so I know we haven't done a shape like this yet, but try this one out. Take a minute, try it out, then we'll go over it. Okay, now it's not showing this side length right here, but it has to be the same as this one. We get to make that assumption, even though it's not a rectangle on this one, okay? So And it may have something to do with the 12s. It doesn't really matter. We get to make that assumption. So we're going to take these and add them together. I'm going to start with these two numbers. I'm going to work my way clockwise around this shape, starting on the left. Again, it doesn't matter where you start. But here I would do 14 plus that 12. 4 plus 2 is 6. And then 1 plus 1 is 2. And then I would add this 12. Again, I'm going clockwise. So that would add from the 26, we're going to add another 12 there. So I'm showing the addition a little different. It doesn't matter how you do it, just as long as we get the same answer. 6 plus 2 would be 8, and then 2 plus 1 would be 3. And then this 14, we're going to add as well for the perimeter. 8 plus 4, 8, 9, 10, 11, 12. So I'm going to carry the 110 over. 1 plus 3 is 4, plus 1 is 5. And then we got this last side length, 12, to add to 52. 2 plus 2 is 4, and 5 plus 1 is 6. So 64 would be the perimeter. Again, we don't have the units on this, but if it did have it, then we'd want to label this. Well, this one is not a rectangle, but it's two. I mean, you could say it's two rectangles been pushed together. It's kind of a weird looking shape. We got to find the perimeter of this one. We just don't know this shape, this line, this length, and we don't know the bottom length here either. But we can find out. So, since like a rectangle, what we're going to do is we're going to say, look at this side length right here, and that's not very straight, but I know it's 90 inches. That means this length, this part of that length also would be 90 inches. So that's kind of a marking for inches right there. And then way over here, again, it's parallel, but that length, which is 32, I can tack onto that 90 right there and say that this is 32 inches as well. So what we want is the full side length, which I'm going to show in green. Sorry, that's not coming out very well. I should put it up. There we go. And to figure out that green side length, what we're going to need to do is take those two lengths, 90 and 32, and add them together. But that will be the full side length in green. So 0 plus 2 is 2. 9 plus 3 is going to be 12. And again, that's in inches. So that full green side length is 122 inches. But we're going to do the same thing with the top side, which is 70 inches. So that'd be this part of it. And there's 70 inches. And then we also have this length right here at 30 inches. So that's the rest of it. It's not very proportional, but that's okay. All right, so we have the orange and blue, which when we combine, we'll make it, make that one red right there. The full length would be the orange, 70 inches. Plus the blue, 30 inches. So when we add these together, 0 plus 0 is, well, 0. And 7 plus 3, boom, 10 in inches. So that bottom side length is 100 inches. Now, I added those together so we can actually see those lengths, but if you wanted to just take the 70 and 30 and 90 and 32, the extras, and then throw those in, that's fine. So again, I'm gonna go clockwise around the shape, starting with the left side length, the big one, 122 inches, which we found. And then I'm gonna add the top side. So I'm gonna work my way clockwise around this. And when I get those two side lengths added together, then we'll go to 90, 30, 32, and then 100. So 2 plus 0 in the ones place value is 2. 2 plus 7 is 9, and then we can drop the 1. Okay, now I can add that red side length, our first one, which is 90 inches. So in the ones place value, 2 plus 0 is 2. 9 plus 9 would be 18, carry the 1. And then 1 plus 1 is 2. Now we'll add the blue side length, which is 30 inches. So 2 plus 0 again is 2. 8 plus 3 is 11, carry the 1. 1 plus 2 is 3, 312. Now we'll add the purple side length of 32. Probably should have made those top ones smaller. But 2 plus 2 now is 4. 1 plus 3 is 4. And then drop the 3. And then we'll add the last side length, that 100 that we found in red, which should should go all the way around the shape. So 4 plus 0 is 4. 4 plus 0 is 4. And 3 plus 1 is 4. That turns out very nice in inches. So our final answer for the perimeter, 444 inches. And again, please do label that. We come up with these values, find the missing length of the trapezoid shown below if the perimeter is 82. So this one, they give us the perimeter. What's wrong with this one is that we're missing this top side length right there, right? We got to find this missing side length. So what we're going to do is I'm going to still look at it like perimeter, meaning I'm going to start on the left, 23. I'll go counterclockwise. The next one will be 43. And then we'll have the 12-incher right there. So if I were to add these all together, it would be missing that purple side length right there in order to get the perimeter of 82. Now, you don't have to look at it like this. In fact, I'm pretty much going to ignore this other stuff for now. But we still need to add these. So let's get started with that then. So 23 plus 42. 43 plus, 43. 3 plus 3 is 6. 2 plus 4 is 6. 66. And then plus the 12. So 66 plus 12. 6 plus 2 is 8. 6 plus 1 is 7. 78. Okay, so the three side lengths that we have add up to 78. But we're still missing that purple side length right there. So kind of like what we're discussing at the end of that last one is we're going to take the perimeter here of 82, and it's kind of like a fact family like you guys did before, right? Because it's really plus that purple side length, and then it would equal the 82. But now we've narrowed it down to 78 plus the blank, or the purple side length, is 82. So again, we're looking at a fact family essentially at this point, where we're going to say, you know what, we're going to take the 82 and subtract the 78, and that will be our missing side length. All right, so let's see what we get on this one. Excuse me. 82 minus 78. So the 2 we'll have to borrow from the 8 and make that 12. 12 minus 8 is 4, which is much smaller than those other side lengths. Again, it's not proportional, and we don't know the units here, but yeah, that one's going to have to be 4. And so we can check this. And we talked about this before. I think on the addition assignment, it was, can you check with addition? Well, yeah, right? Just add these 12 plus 43 plus 23 plus 4 and make sure that it does actually equal 82, and it does. So we're good.